Okay, in this lesson we're going to look at arithmetic progressions. Now progressions refer to both sequences. All right, so remember what a sequence is. It's just a bunch of numbers that are in some kind of order and they follow a rule. Right? That's a sequence. Progressions, this term progressions, which we're going to use a bit, refers to sequences and series. Right? So progressions, sequences are distinct from series. So a sequence, right? So remember, a sequence is just like 1, 3, 5, whereas the series is 1 plus 3 plus 5. Now, an overarching term for sequences and series are progressions. Now, progressions, so if we talk about progressions, we're talking about either sequences or series. All right, so just so that you understand, when I talk about an AP, it's an arithmetic progression. When we move on to geometric progressions, we'll refer to them as GPs, just to talk to each other. Okay, so arithmetic progressions. Now, the other thing about this is that arithmetic progressions have a recursive feature that they are just adding a number to the number in front. All right, it's the most basic form. So arithmetic refers to a recursive addition, right? And a recursive addition, whereas geometric referred to a recursive multiplication. There was a question in the exit ticket, and it went something like this. Was it, maybe it started 5, and the question was, what type of sequence is it? Well, because the rule is from term to term is multiplied by 3, if it's multiplied, it's geometric, right? That's a geometric recursion or a geometric progression. Multiplication is geometric, arithmetic is addition. So, right, so let's get that's important to get clear up front. Okay, so recursive, the recursive feature of arithmetic progressions are that, okay, so we always talk about the first term in an arithmetic progression is U1, right? So the first term is just U1. Now the second term, so recursively, our second term would be the term in front plus some common difference, right? Whatever they're going up or down by. If D is negative, it'll be a sequence that is going down, right? That's negative 6. So D in this case would equal negative 6. D in this case would equal 2, because we're just going up by 2 each time. So D would equal 2 here, and D would equal negative 6 here. Okay, so as a recursion, an arithmetic sequence will just follow like so. So if we want the nth term of an arithmetic, then we just need to know what the n minus 1th term is and add D. All right, so that's our recursive rule for arithmetic progressions. Okay, how would it look as a list? Well, if we listed out our arithmetic progressions, again, if we just went with a general expression of an arithmetic progressions, it would go like so. It would be U1 for the first term. Now, rather than write U2, U3, U4, it's not really telling us much. It's U1 plus this D, this common difference, right? U1 plus D, and the next term, well, it would be U1 plus D, wouldn't it? Right, we take the term in front and add a D, but we don't need to do D plus D. We can say that's 2D, right? And it goes on. So the nth term, in fact, our nth term I'll save for the general term, because that will be the next, on the next line. What would be the next? It would be U1 plus 3D. Sorry, I got lost what I was doing there. So the general term will be, our nth term is going to be our first term. If you have a look at this, see each term, that's the first term, this is the second term here, this is the third term. All right, so what's happening here is we've always got the first term plus some multiple of D. Now that multiple of D is always just one less than the term number we're looking at. So this was the third term here, and it was U1 plus 2D. The fourth term was U1 plus 3D, just one less than D. So here we have our general term for an arithmetic progression. That's a really important result, and it's one we're going to use a fair bit. Now we're going to go through some examples, and we'll see how this plays out. Now what we're going to do today is we're going to do a couple of examples, then I'll point you to the exercises. It's exercise 1B, and you can practice what we've done, what the example has talked through. So we're going to really chunk it up quite neatly like that. So first example we'll look at is, let's say it might be, so find the nth term. I'll just pause here. So here's an example, find the nth term of this sequence, right? 1, 6, 11, 16. So we can see that it's going up by, we're just adding 5 each time, so the recursion is to add 5. So D is equal to 5. So here we go. Let's construct our solution. So we might say, okay, so D is equal to 5, and U1, our first term, is equal to 1. So the nth term will go and tap into this general term expression that we just generated. So we can go over here and say, well, therefore the nth term is going to be U1, which is just 1, plus n minus 1d, so n minus 1 times d, which is 5, right? So this can, we're more used to seeing it in this sort of fashion, and that is 1 plus 5n minus 5, which is equal to 5n minus 4. Now you might have, and in fact we have been doing questions like this. As soon as we see the plus 5, we've already worked with these kind of expressions before, and without really talking through what the method was or how we came up with the nth term, we did it in this way. We said, well, that's adding 5 each time. Well, that's just because we're going in 5s. That's like a linear relationship. We're going up by the same amount each time. So it's 5 times n, and then we've just made the adjustment. So if I just left it like that, that would be 5, that would be 10, that would be 15, that would be 20. So our blue numbers are 4 less. So that's pretty much what we've done. What we're doing now by use of this general term formula is that we're just being a little bit more precise about it. We're applying a method, and that method has really just come from what we've defined as an arithmetic progression, and that is just adding d each time, adding d. Okay, so what you can do now, and what I'd like you to do, I think, is to go and do question 1 from exercise 1B. And then once that's done, head on back and we'll go through the next example. Okay, so hopefully question 1 was okay. Now in example 2, right, we have this sequence here going from 8 to 2 to -4 to -10, where we're dropping by 6 in each case. So my D value is -6, and my U1 is 8. My first term is 8. So tapping into my general term formula, I am going to write UN is equal to U1 plus n minus 1 times my common difference. Now I'm after the 10th term of this sequence. I've got the first 4, I want to skip to the 10th. Okay, so how do I do this? I write U10 is equal to U1, well that's 8. Now I don't, n in this case is equal to 10, so this will be 10 minus 1 times my common difference, which is -6. So therefore, U10 is equal to 8 plus 10 minus 1 is 9 times -6. So 9 times -6 is -54, and 8 plus -54, we all know, is -46. So -46 is going to be our 10th term. All right, so questions such as that, you can now practice with question 2 of exercise 1B. Now, that's again got 4 parts. You don't have to do all 4, just maybe you do 2. You can do all 4 if you like, but keep coming back to this screencast and we'll do another example or 2. Okay, next question. So the number of terms in the sequence, so find the number of terms in this sequence. So it goes 20, 23, 26, all the way through to 83. So my U1 is here at 20, and my D is equal to 3, and this is my UN. I don't know what N is. I'm trying to find out what N is. All right, that's my challenge. N is what? Okay, so UN, which is 83 in this case, UN, which equals 83, is equal to, okay, off we go, U1, which is 20, plus n minus 1. See, I don't know what n is, so I can't substitute that in. That's going to be what I'm trying to find. N minus 1 times d, which is 3. Okay, so here I have an equation, one unknown, which is n. I just need to go ahead and solve. Therefore, 83 is equal to 20 plus 3n minus 3. Get to work on this. Therefore, 3n is equal to, what's this, 17. 83 minus 17 is 66. So dividing by 3, n equals 22. So therefore, and I should finish this off with, therefore, there are 22 terms in this sequence. All right. Or in other words, 83 is the 22nd term in this sequence. Okay, you're good to go with now questions 3 and question 4 from exercise 1B. See you soon. Okay, for our last example now for this lesson, let's read through this question. The second term of an arithmetic sequence is 20, and the seventh term is 55. Right, so the second term, and as this information unfolds, let's write it down. So U2 is 20, and U7 is 55. Okay, so it's good to put these, just to rewrite, put the words into our symbolic language, if you like. So find the first term. So we want U1. All right, so maybe in a different color, I'm going to put down what I'm trying to find. So U1 needs to be found. I need to find D. And ultimately I need to find the 20th term. Okay, so these are the challenges. This is the information I have. Now, how can I use this information? Well, U2 equals 20. Well, I know that U2 can be written as U1 plus D. So U1 plus D must equal 20. Okay, now the seventh term is 55. So how can I rewrite that? U7 is U1 plus 6D, isn't it? And that's equal to 55. Looks to me like we have two equations, and I need to find values of U1 and D. I've got two equations in two unknowns. This looks like simultaneous equations. So if I go to, perhaps I'll take equation 2 and subtract equation 1. All right, so equation 2, U1 minus U1, so they'll disappear. 6D minus D is 5D. 55 minus 20 is 35. So D is equal to 7, and if D is equal to 7, I can plug D equals 7 back in here, and I can easily see that U1 must be equal to 13. So there are my values of U1 and of D. Now I just need U20. Now U20 is U1 plus 19 times D. Okay, that's going to be equal to my U20. U1 I know is 13. D is equal to 7, so it's 13 plus 19 times 7. Okay, that's going to be equal to my U20. So therefore, U20 is equal to, well, what do we got here? 13 plus, what is it, 140, 133? 10 sevens are 79 and 63, 7, so 10, 70 plus 63 is 133, yep. So my 20th term will be 146. Okay, so that's how to do that kind of question. When you're given a couple of bits of information, make your equations up using what we know, which all gets back to our general term, and solve simultaneously. Nice. Okay, you'll see questions 5, 6, and 7 are very similar in here. Now you can get a bit of practice. You can do 8 as well. This is from exercise 1B, and that's as far as we'll go today. Next lesson we'll look at arithmetic series. So we will look at, as remember, progressions, sequences, and series. This is all to do with arithmetic sequences and how to find certain terms and find out bits of information about the sequences, find certain terms, find how many terms are in a sequence, so unlocking some clues and working things out. What we'll do in the next screencast, next lesson, will be to take sequences and find their sums. So next will be arithmetic sums or arithmetic series. All right, and that'll be things like like so. Find the sum of the first 10 terms of such a series. Anyway, I'll see you in class on Thursday. Cheers.